once again welcome to our channel Physi Dive, and this is your teacher Alexi Rajan. So today we are going to study about a very important topic of class 10 NCERT, that is spherical lens. So we are going to study about what are the different types of lenses and what are the terms related while studying the spherical lenses. So without wasting time, let us dive straight to the class. So to the class. So we have studied about the refraction process in the previous classes. So there we have seen refraction cases are like this. If you have an interface which separates two medium, that is medium 1 and medium 2, then a light ray comes from one medium or medium 1 to medium 2, then definitely if there is an optical density change, then definitely it will bend and moves like this according to where is a rare medium and denser medium. Not getting into that all those stuff, because you can go through the previous videos. I will pin somewhere here. You can kindly go through that video and come to this session. Okay, now you can see if there is a normal here, then definitely it will move towards a normal or away from the normal according to the situations or scenarios given there. This is the part of refraction. But in order to study this refraction process in detail, we have to use one particular instrument, optical instrument, and that is known as what? Lens. And as we are studying about the spherical part of a lens, we are going with the spherical lens precisely in our class. So in our class 10 NCERT, we have to study specifically about two types of lens, and that is convex lens and concave lens, same as that of the mirror part. Convex lens looks like, and here you can see the middle portion is a bit thicker and the edge portion is thinner. This is thinner, and here the middle portion is thicker, and this is known as what? The spherical lens. Or more precisely, we can say that a lens is like this. That is, if I am taking a convex lens and if I am passing light through this lens, then definitely it will enter refraction process takes place and it goes like. You can also see that if you're taking a convex lens, then definitely if I am passing one or two ray of light, then definitely it will just converge and meet at a point. So this lens is also known as what? Converging lens. In the previous case of mirror, it was just the opposite. That is, convex mirror is what? Convex mirror is a diverging mirror and concave mirror is a converging mirror. But here in the case of lens, it is just opposite. That is, convex will become converging lens and this concave will come to that particular point right now. So in this case, you can see how a concave lens looks like. A concave lens looks like this. That is, you have a lens here and the middle portion is thinner and the edges are thicker. So this type of lens is known as what? Concave lens. And if I am taking a concave lens here, if I am taking a concave lens and if I am passing one or two rays of light, parallel light, then definitely I can see after refraction, this light will diverge and moves. So we call this concave lens as what? A diverging lens. So I hope that you got the points there. So I will show you in details, that is how a convex lens and concave lens looks like in real. So to the video. So now here is the video, the real-time video. Okay, fine. There are two lenses here in front of you and you need to find what type of lens are given to your hands. So how will you find it out? So by the definition, you can say I'm just taking the first lens there. Okay, fine. And how can I identify this lens? The edges are thin and the center portion is bulged. So this is what? A convex lens. And then the center portion of the lens is known as what? The optical center. So here comes the convex lens. Now the second lens, if I'm taking this lens, okay, in my hand, you can see the edges. This edge is a bit wider, right, than the center. The center portion is what? Curved inside, a bit curved inside, whereas the other part is exactly the opposite. The center portion, the edges are a bit thicker, and we call this particular lens as what? This lens as the concave lens. Here the thickness is very less. That is why the thickness are not convenient in the camera, but still you can see the convex lens is such a way that the middle portion is thicker and the edges are thinner. Whereas a concave lens, the middle portion are thinner and the edges are thicker. So this is all about a concave and convex lens. Now you may have a doubt that how it is made of. Imagine that if I am taking a convex lens, then definitely it is made from two transparent spherical glass. So you can see that here also one spherical glass is there. So you merge both the spherical glasses together and you will get a portion out of here, and it looks like this. You cut the remaining portion and then you will get what? A convex lens. And here how you make a concave lens. So let us see that if you take a convex lens here, then if you consider the two sides of the lens as a sphere of glass, then it looks like this. You combine it together and then you will get a concave lens, and you just delete all the other portion and you take the middle portion, the converging or the union portion, and then you will get what? You will get a concave lens. Here you will get a convex lens. So here also you can see that there is a converging or there is a mixing of two spherical glass material. And here this convex lens and concave lens that we are taking under consideration or we are studying in class 10 is also known as what? Convex here and convex here, and here it is biconcave. Why it is called bi means two, and here two surfaces are there and it is made up of two spherical portions. So that's why we are calling it as biconvex, and here we are calling it as biconcave. Okay, that's all about the spherical lenses. So now we can just see what are the different terms related to this particular lenses. So here comes a convex lens. So the center of the convex lens is known as what? It is known as the optical center, and it is denoted by the letter C, or in some books you can see it is denoted by the letter O, which represents the optical center. Okay, so this is about the optical center. Whereas in the mirror case, it was not optical center, instead it was what? The pole. It is denoted by the letter pole. And the next term that you need to study, you need to undergo is that this line, that is the line which is passing through this optical center and perpendicular to the surface of the lens, and is passing through the optical center, and we call that line as what? The principal axis. Now, a very important term, that is a principal focus. So here you can also see that two surfaces are there. So definitely here there will be two foci or foci. You can pronounce it as foci or foci. So you have two foci. Why? Because two surfaces are there. So whereas in mirrors only one surface, reflecting surface is there. So that definitely there is no issue of two foci there. But here you need to adjust. You need to deal with two foci there. And so we'll study about the principal focus in details right now. Imagine that there is a convex lens in your hand. And we also have seen that this convex lens is also known as what? Converging lens. Why? Because the light rays which is falling on this convex lens will converge and pass through a particular point. Same as that in the mirror case. So those who haven't gone through that mirror, kindly go through that mirror videos. I will pin there so you can go through it and come back. Then it will be very easy for you guys to understand the concept here also. So then it is also known as a converging lens. So what happens there? Here comes a small experiment. Okay, fine. Here you can see I am using a beam of light here, and there's a stand there to keep the lens there, and there's a screen there. You can see the screen. If you observe the screen, you can see there is the lights are dispersed throughout. Okay, fine. Now if I'm keeping a convex lens there, just see closely. Yes, now see the screen there. The light falling on this particular lens is converged and focused on particular point, focused on this particular point, right? And here, this is why a convex lens is known as what? A converging lens. Converging lens. Why? Because almost all the light which is falling on this surface of this particular lens is converged and focused on this particular point there on the screen, and we call it as what? A converging lens. Just imagine that you are passing a light rays or beam of light. Beam of light means a group of light, okay, which are parallel to each other. Then definitely you can see that, okay, here is another ray, here is another ray. All the four rays are parallel to each other. Then definitely what happens there, after refraction, you can see this ray pass principal axis. Then you can see, if I was examining the second ray, then also you can see it is converging and passes through this particular point. A particular point is there on the principal axis, and you can see all the light rays which are after refraction will pass through that particular point and converges or passes or converges through that point, and there forms a point here. Here you will come across a particular point, and through that particular point on the principal axis you can see that all the refracted rays are passing by, and we call that particular point as what? As principal focus. So this is a case there. And now it is denoted by the letter capital F. So I'm thinking that you are getting the concept there. So principal focus means the focus on principal axis. And here the next condition is that all the light rays should be parallel to each other. They should be parallel to each other there. Then you will get a principal focus, and parallel to each other, as well as they should be parallel to the principal axis. Then you will get principal focus. And there will be many foci here, but that is not principal focus. There will be only one principal focus, and there will be many foci. And this is a case there, and it is denoted by capital F. And in the case of lens, I already mentioned that there will be two foci, there will be two focus, and here there is a distance, or the distance between this optical center and the principal focus is denoted by small letter f, and that is known as what? The focal length. And here there will be a distance, right? Just calculate the same distance from the principal focus in the opposite direction, then you will get another point here, and this point is f dash, and this two f dash and f are the two foci, are the two focus for this particular convex lens. I hope that you are getting the points. So just go through this once again, and you will understand the logic, you will understand the physics behind that, and you will understand the concept behind this particular focus. This is all. That's all about the principal focus for a convex lens. Now what about concave? How you deal the principal focus of a concave lens? So let us see that also. Here comes the concave lens, and this concave lens is also known as what? Diverging lens. So here also the center of the lens, which lens? Here a concave lens is given there. The center of the lens is known as what? The optical center, denoted by C or O. And here it is the optical center, denoted by C or O. Now the imaginary line which is passing through this optical center, and which is perpendicular to the surface of the lens, that is perpendicular means 90 degree to the surface of the lens. Which lens? Concave lens is known as what? Principal axis. And this is principal axis. Now this lens is also known as what? Diverging lens. Why this is known as a diverging lens? Okay, if I am passing a light through it, okay, before that I will just rub all this thing. If I am passing a beam of light, just say this is first beam and this one is a second beam, and they are parallel to each other, and they are parallel to the principal axis also. Then what happens there? After refraction, you can see that this beam of light refract in such a fashion that they diverge each other. That is, they are moving apart. They are moving apart, so we call it as what? We call it as what? A diverging lens. And in the case of a mirror, it was in the just the opposite. Concave mirror is known as what? The converging mirror. But here it will be the diverging lens, and concave lens is known as a diverging lens, and this is a case there. But here we need to study about the principal focus. So how can I get this principal focus here? How will I understand the concept of principal focus here? So just listen. Imagine that if two rays of light are moving like this, they are parallel to each other, and they are parallel to the principal axis. Now, in this case, you can see they diverge after refraction. There is no point, there is no way of in such a fashion they meet each other in real. But what will we do if we are getting such a condition, such a scenario? We know that in the case of mirror, we have studied that if the light rays are refracting or the light rays are reflecting after the reflection process, then in such a fashion they diverge each other, then what will you do? You will extend it backward or extrapolate it backward. The same way we will do it here. That is, here in this case, the ray 1 and ray 2 both are diverging each other. So they will not meet in real for sure. So you will just extrapolate this thing, and that is the first ray will be moved back. Okay, I'll just use this color itself. So the first ray is moved back and it meets at a point somewhere here, that is this particular point on the principal axis. And if you just extrapolate the second ray also backward, then you can say that you can see clearly that they also meet at this particular point here. Okay, so both the light rays, after extending it backward or extrapolating it backward, you can see they meet at a point virtually. That means it feels that, or it seems that from this particular point, both the light rays are passing by or just originating and just passing or just liberating. So we call this particular point as what? The principal focus. And it is denoted by capital F. And the distance from optical center to this principal focus is known as what? Focal length. It is known as the focal length and denoted by small letter f. Now, you just calculate exactly the same distance in the opposite direction. Then you will get another point here, and that is nothing but f dash, capital F dash, and that is a second foci of this particular concave lens. So two focus there, and the foci are f and f dash. So here also you are just getting two focus, and here the next thing is that you are virtually getting the focus there. And why? Because it is a diverging lens. I hope that you are getting the points and you got the points. The same concept that we used in the mirror is again used in the case of lens, and you are getting the same result, but the terms are different. That is, there it was concave, here it is convex. There it was convex, here it is concave. So that's the only difference there. So that's all about the terms related to this particular lens. Previously, in the case of mirror, we have studied about center of curvature and all. Here, there is no importance of center of curvature there. Instead, we will just take another point, that is, in the case of both lenses, exactly 2 times the focus there, and there you will get another point that is nothing but 2f dash here, and here you will get exactly the same distance, and here you will get another point that is 2f. So in the case of convex lens also, you will get 2 more points, that is 2 times the focus, principal focus, that is 2f and 2f dash. So these are the terms, these are the points that we need to study while studying the concave lens. Here also we'll study the image formation by the convex and concave lenses there in the next class. So that's all for today's class. I hope that you got the different points, what are the different types of lenses there, specifically concave and convex lenses there, and what are the different, which lens is diverging lens, which lens is converging lens, and then we have studied the different terms related to this particular lenses, and these terms are very much important to understand the concept of image formation by the lenses. That's all. And we need your support. Keep supporting, and we need your support in terms of your like, share, subscription, and comment. So we'll see you in the next class. Till then, goodbye and have a nice day.